Here we've got a slightly more complicated absolute value function, and I've already drawn y equals the absolute value of x that we've already had a look at here. But just as a comparison, let's have a look at y equals the absolute value of 2x and compare that. Is there any difference with y equals 2 times the absolute value of x? Now, we've already seen a rule earlier today which said that the absolute value of things multiplied together is equal to finding the absolute value of each one and then multiplying them. So a quick examination of this tells me that 2 is always positive, and x, once it's absolute value, is always going to be positive. So whether you multiply them together after they're both positive, or whether you multiply them together and then make them positive, you can see from my tables of values down here, we get the exact same result. And I've really just put these out to highlight to you that if you're confused with these, or you get any of these rules mixed up and you need to graph an absolute value function, one of these tables of values is your friend. It will always help you do this. Now, what we're basically needing to graph here for both of these is the line y equals 2x, which goes through the origin and goes up more sharply with a gradient of around 2. So I can graph, let's name it y equals absolute value of 2x. It does the same thing. It gets down to here and it bounces back up the other side. And it has that same sort of symmetry. It's an even function, and you can see why when you look at the table of values.